Hello, welcome back to my channel. We continue to review the construction materials, methods, and techniques textbook. This video is about chapter 8, and that is cast in place concrete. So in this chapter, we will discuss the processes for preparing, transporting, handling, and placing cast in place concrete. Then we'll see how cast-in-place concrete walls, beams, and columns are formed, reinforced, and poured. And then we'll talk a little bit about the finishes that are used on concrete surfaces, and we'll see how concrete is cured. Also, we'll see a few different types of formwork used for cast-in-place, cast-in-place concrete, and then identify and describe types of concrete reinforcing materials. Also, we'll take a look at the sketches, and again, you should definitely refer back to the textbook, and those sketches illustrate the various types of monolithically cast slab and beam floors and roofs. So, and the last couple paragraphs are dedicated to the procedure for casting and erecting tilt-up concrete walls and lift slab construction. So again, this chapter is the continuation of chapter 7, which is the concrete. So if you did not see that video, you can go back and actually click on the video series. There's like a playlist, and you can refer to chapter 7. So when we talk about the building codes, they prescribe what type of construction should be used. And concrete, for the most part, is not environmentally friendly, but it's a very durable construction. And let's see how actually that is prepared and handled and designed and constructed. So when we prepare concrete, there are a few things that we need to remember. So concrete is prepared in what are called batches, and a batch is the amount of concrete mixed at one time. And usually it's pretty much like a monopoly, because the concrete can stay in the concrete mixer for not more than 90 minutes. So transportation needs to be really local. You cannot transport that too far, because the concrete will start to cure. Then concrete is mixed until it is uniform in appearance and all ingredients are evenly distributed. It can be stationary mix, or it can be ready mix concrete, or it can be actually remixed just to make it a little more fresh, or like if the water is added, so it's more workable. When we transport and handle concrete, so there are concrete pump trucks. They use heavy-duty piston pumps to force concrete through a pipe mounted on a mast, and that's I'm sure you've seen that on many construction sites. And ready-mix concrete can be discharged directly from a truck mixer to its final location, which should be prepared, and the formwork needs to be in place, and the reinforcement needs to be in place, if any. So concrete pumps are heavy-duty piston pumps. We know that, and they need access around the building. So if you pour concrete, you need to plan for that. Placing concrete in cold and hot weather have their own difficulties. So please make sure that you adhere to the manufacturer's recommendations as far as the cement when you choose that. And also you need to know the curing temperatures, and you need to protect the concrete. And this is what these subchapters are about. When we finish concrete, there can be a few things that we need to remember. An initial screeding, also called strike off, involves removing excess concrete with a screed to scrape it flush with the top of the formwork. And then we get a desired surface. Also, control joints can be formed in wet concrete, or they can be sawed after concrete is hardened, or they can be actually formed by inserting plastic or hardwood strips in the concrete. Isolation joints. Isolation joints provide a space between a slab and the wall, and that allows each to move without disturbing the other. And that is, for the most part, needed in the earthquake-prone zones. Construction joints are formed where one pour ends and adjoining one meets it. So that's like two different pours of concrete. When we talk about curing concrete, we spoke a little bit about that in chapter 7. When the water is added to the Portland cement, it produces a chemical reaction that is called hydration. So we need to remember the ratio, the concrete to water ratio, and that actually will be prescribed by the manufacturer and the structural engineer to achieve the desired strength. Also, this chapter talks about the formwork, and it can be, it's always a temporary, no, actually, it's not always. It can be a temporary or permanent mold in which concrete is poured. And the reason why I said always, like for the most part, it's temporary, then it's removed. But sometimes there are situations when we cannot remove the formwork, so it stays there. For example, if it is against the wall of the existing building, then there is no way we can remove that on the side that is adjacent to the existing building, for instance. Or sometimes it is left intentionally in place. It can be reused if that's the metal mold, or the formwork can be made of plywood or other materials that can be actually broken when they are removed. So usually it's good to use a reusable formwork just for the sustainability purposes. Again, refer back to the textbook. There are a lot of sections here showing, for example, the site build plywood form assembly. And also you can see the panelized or modular forms that are prefabricated and that can be reused. Actually the building erection goes pretty fast. Also, you can see the snap ties that hold forms at required width, and that's something that you need to be aware of. So please refer to all these images here. There are a lot of them. Let's talk about the concrete reinforcement. And there are a few materials that can be used. So steel reinforcing bars, or rebars, is the most popular material that is used for the beam and slab and wall reinforcement. Also, it can be a welded wire reinforcement. That's another type of that. And also, please refer to the chart, and you can see how actually the rebars are sized, and they're sized 1/8 of an inch. So please make sure that you're familiar with the sizing and that you actually use the right one. What else is important here? There are a few charts showing the how the bars are cut to length, and also some of the standard bends that are used with steel rebars, and also the engineering plan and section details for the cast in place structural members of a building. So those are the drawings that will really help you understand the process. Also, the concrete reinforcement can be a fiber reinforcement, and we need that to make the concrete lightweight, and in the spaces where we cannot use metal, for example, if it's like MRI equipment or something like that sensitive, so we cannot use metal, but we can use the glass fibers or like polymeric fibers and so on. So cast in place concrete elements. There can be casting on grade slabs, and we spoke a little bit about that in chapter 7. There's more information on that, and you can see how that is designed and constructed. Then it can be cast in place reinforced concrete walls. Again, refer to the sections, and you can see how that is being reinforced. Then reinforced and cast in place beams, you need to pay attention to where to place the rebars and where to um, put the tendons and other reinforcing elements. Then when we reinforce cast in place columns, it's a different procedure as well. So please make sure that you review all of them. So when we talk about cast in place concrete framing systems, there are general construction procedures. Please refer to them because they are applicable to most of the construction processes. And then the different slabs are reviewed here. So there, you can have a one-way flat slab. Then you can have one-way flat slab with beams and girders. Then another type is one-way flat slab with joists and beams. And again, they all play different role. And for example, if your floor-to-floor height is sensitive, you may just use the flat slab, and just that will create the highest ceiling possible. Then we talk about two-way flat slab and that's generally for the spaces that are more square in the plan. And there are a few variations of that. So it can be a two-way flat slab, it can be two-way solid slab, two-way flat plate, two-way joist, or waffle flat slab. And again, they are all different. They have different structural load, they have different visual appearance, and of course, different cost, because that plays a lot of that plays a big role when we talk about the concrete construction. Let's talk a little bit about the tilt-up wall construction, and that is cast in place, and that is basically cast horizontally, and then the crane tilts it up and lifts it up, and that becomes a wall. And another type is lift slab construction, and that's actually casting a reinforced concrete slab for each floor of a building and the roof, one on top of the other. So again, please refer to the images here. So that was it for our chapter 8. I will see you in chapter 9, and we'll continue the conversation about concrete, and that will be a precast concrete. Thank you so much for watching. I'll see you in chapter 9.